Wall-to-panel subconstruction framing. The drained and back ventilated rain-screened facades we promote hold the panels away from the main wall. To keep the panels in place, a subconstruction or supporting frame is needed to connect the panels to the wall. Normally, a wall bracket connects the profiles to the wall. The vertical profiles support the panels. This creates a cavity space, which is an ideal position for the insulation. The panel layout can have a big influence on the amount of large or small profiles needed. When meeting the architect early in his design process, it can be helpful to discuss this. For example, using the same size panel in a vertical pattern will result in a different subconstruction layout than if the panels were arranged horizontally. Other influences include having staggered joints or free patterns using different size panels. Firstly, we will look at the wall structure, insulation, then the cavity, before moving on to the subconstruction, and finally addressing some design principles. Wall structure. The main structural wall can be a timber or metal lightweight frame or a massive masonry construction such as concrete or brick. This structural wall needs to carry the weight of the facade and resist the power of the wind. It should also be airtight, especially around openings such as windows. Airtightness prevents moisture, ingress, and ensures that the building remains thermally efficient. Insulation. In this section, we will look at how to insulate the facade and prevent thermal bridges. How to insulate the facade. The insulation, be it a mineral wool or a foam-based material, must be thick enough to suit the building's function. Each product has its own characteristics and level of performance. Ideally, the insulation should be fireproof, water-resistant, and breathable. To meet these criteria, a number of insulation suppliers have a board for ventilated facades. Whichever insulation board is chosen, they must all be securely fixed to the structure, which is normally with special fastenings. Over time, the insulation must not sag or bulge out to block the air cavity. It is important that the insulation has no gaps at its joints and fits tightly around the subconstruction to reduce heat loss and the effect of cold bridging. How to prevent thermal bridges. As the subconstruction connects the panel to the wall, it can act as a bridge over which heat can travel. This will reduce the overall thermal performance of the wall. The designer's choice of subconstruction can have an influence with this concern. For example, timber performs better than aluminium. To help eliminate this bridge, thermostops are used with metal wall brackets. This is to break or isolate the metal from the structure and to prevent transfer of heat. Other solutions which address this issue are being continuously developed. Cavity. Now we look at how the facade is ventilated and how to prevent the passage of fire. The minimum cavity width should be 20 millimeters. This will permit both air movement to evaporate moisture and a drainage path for water to run down the rear of the panels and out at the bottom of the cladding. Please note that this 20 millimeters is only suitable for low-rise buildings and will increase as the building gets taller. Air must be allowed to enter at the base of the facade, travel unobstructed up the wall and exit at the top. Openings at the base, parapet or under and over windows should be provided. These openings must be protected with a perforated profile which maintains the airflow and importantly prevents the entry of vermin and birds into the cavity space. One challenge that arises from time to time is how to prevent the passage of fire in the cavity. Promat's ventilated cavity barrier remains open until a fire causes it to seal up. To Today, 3 types of subconstruction material are commonly used to carry our panels. These are aluminium, galvanized steel, or timber battens. Our panels are strong yet light, which reduces the amount of subconstruction needed. This gives us an advantage over some of our competitors. The position of the panel is determined by adding the thickness of insulation to the cavity width and allowing a little extra as a tolerance for uneven walls. Whichever subconstruction is used, the wall should be checked by the installer prior to installation to confirm that it is flat and to ensure that the correct fixing and details are used. Aluminium. The most widely used subconstruction is an adjustable aluminium system. Mark the position of the wall brackets as shown on the layout drawings. Securely fix the wall brackets with their thermostops to the wall with suitable screws or bolts. Place the insulation against the wall. Using the clip on the wall bracket, insert the vertical T profiles behind the vertical panel joints and the L profiles as the panel's middle support. When final positioning is confirmed, fix the profiles. The wall brackets are arranged with fixed and gliding points. Each length of vertical profile has one fixed point wall bracket. This is positioned either near the top or in the middle of the vertical profile. The fixed point wall bracket, which carries the weight of the cladding, is normally the larger of the two. The rivet or screw is placed in the holes of the bracket to lock the profile in place. Make sure the fixed points are kept at the same level around the building. The other wall brackets, which are smaller, are the gliding points. The rivet or screw in these is inserted into the elongated holes. This holds the profiles in place while still allowing them to move freely up and down to accommodate the thermal expansion of the aluminium. It is important to always leave a 20mm gap between the ends of the vertical profiles. This must coincide with a horizontal joint between the panels. No panel should be fixed to 2 different rails, as the movement in the metal will cause the panel to crack. If uncoated profiles are used, their silver colour, which can reflect sunlight and give an unwanted appearance, can be hidden by using black tape or paint behind all panel joints. Galvanized steel. Although the thermal expansion of galvanized steel is not the same as aluminium, the fixing procedures are similar. The wall brackets are still arranged as fixed and gliding points. Leave a gap between the ends of the vertical Omega and U profiles and conceal them by applying the black tape or paint behind the panel joints. There are 3 options for timber subconstruction: adjustable, non-adjustable, and the distance screw method. The grade of timber suitable for use in a ventilated facade and whether it is to be treated with preservative can differ from country to country. The batten should be a minimum of 30mm thick. Battens used behind the vertical panel joints or at corners should be 90 to 100mm wide, with the other battens 50 to 60mm wide. Ideally, the batten should be smooth on the front face and one edge to ease levelling. EPDM or aluminium protection strips are placed on the face of all battens. This helps to protect the timber and gives an added benefit of providing a black shadow gap to the joint. To accommodate the insulation and maintain the cavity, the vertical battens are fixed back to the structure in a number of ways. Adjustable system. This system utilises the Eternit adjustable bracket to carry the vertical batten. This allows for batten adjustment for uneven wall surfaces and can accommodate insulation up to 100mm thick. The bracket with its thermostop is fixed to the wall with suitable bolts or screws. The brackets alternate to the left and right of the batten to ensure stability. Brackets for neighbouring battens are also staggered horizontally. 50mm thick battens are held in place with 4 stainless steel wood screws. Any levelling can be made before final tightening of the bracket bolt. Non-adjustable system. One way is to fix a series of counter battens horizontally across the wall and in filling them with insulation. Over these, the vertical battens are securely fixed at centres to suit the panel layout. This method is dependent upon having a level wall, as adjustment is limited and is normally used where thin insulation boards are specified. Distance screw system. The distance screw concept utilises special structural fixings which are able to carry the weight of the facade without the need for brackets or profiles. This method reduces the effect of thermal bridging. Design principles. The designer or engineer needs to consider a number of factors, such as the effect of the wind and the building's location. Referring to the architect's drawings, the engineer will calculate and design the framing based on the panel layout. This design will show the position of the profiles, brackets, fixings, and any special details. The effect of the wind. The main issue is the wind and what effect this will have on the cladding. Wind blowing onto a building will give rise to pushing or positive pressures on the front face and pulling or negative pressures on the sides and rear of the building. The negative pressures on the side walls will generally be greater at the front end and reduce further back along the building towards the rear. This means that the wind is trying to pull the panels off the wall. This is known as wind loading and is expressed as kilonewton per metre squared. External corners are one of the most vulnerable areas to wind. As well as the wind pulling the panel from the outside, the back of the panel can be also subjected to pushing from the cavity. To counteract this, a continuous vertical cavity closer is introduced so that the wind pressures are separated. Another solution is to fix extra supports on both sides of the corners of the facade. The building's surroundings may also affect the design. For example, where two buildings are close to each other, funneling will accelerate the wind flow and increase the negative pressures on the facade. The effect of the building's location. As well as the wind, the building's location also has an effect on the facade. Factors such as, what is the site's altitude above sea level? How far is the building from the sea? What is the local topography? Is the building in a city or in the countryside? How tall is the building? All need to be considered in the final design. We believe that finishing the building with a ventilated facade or rain screen cladding is the best solution for both the building and its occupants. While our panels give the building its good looks, what happens behind the panel is an important part of a successful facade.